In this section, we're going to look at comparing decimals. So looking at which number is higher or lower than the next. And sometimes we'll also be comparing decimals to fractions, remembering that a decimal is just a special type of fraction, and eventually we'll be comparing percents to those as well. When we worked with fractions, remember that we used the benchmarks 0, a half, and 1 to gauge the size of fractions. And we're going to do the same for decimals. That is always my first method that I would use when I'm trying to compare decimals. So if, for example, if we look at this first column, all of these are decimals and their equivalent fraction that are close to 0. So anything that starts with 0.1 or a 0.0 something, all of those numbers, all of these values are close to 0. They're just a little bit more than 0. Anything where the first decimal is close to 5, so here we've got an example of a 6, a 4, and a 5, all of those are close to 1/2. 0.5 is exactly 1/2, and these three decimals are all close to 1/2. And then these decimals are all close to the number 1. Anything that's starting with a 0.9 or 1 point something that's close to 0. So a 1.0 something is also going to be very close to 1. So if we look at this first example here, where we're ordering these three numbers from smallest to largest, we can take a look at them and just think through which one is close to 0. And you can see that this last one, 0.091, is close to 0. The 1.1 is close to 1, and it's a little bit more than 1. And the 0.53 is close to 1/2. So to go from smallest to largest, we'll do 0.091. Then the one that's close to 1/2 is 0.53. And then 1.1 is close to 1. Let's look at the second example here. Again, we've got a number of decimals, and this time we have some fractions as well, and we want to order them from smallest to largest. So if you look at the list, let's look for the values that are close to 0. So the 0.07 is the only one that's close to 0, so it's going to be our smallest. So we'll write it first. Then let's look at the ones that are close to 1/2, and actually we can just put a line through the one that we're finished with if that makes it easier. If you look for the ones that are close to 1/2, we've got the 0.489, that's just a little bit less than 1/2. And we have the 9/16. They're both close to 1/2, but if you think about 9/16, 8 is exactly 1/2 of 16, and 9 is more. So 9/16 is a little bit greater than 1/2, and the 0.4 is a little less than 1/2. So the 0.489 will be next, and then the 9/16. So we're finished with those two. And now we have two numbers left. 0.95 is a little bit less than 1, and 9/8 is a little bit more than 1 because it could be written as 1 1/8. So to finish this one off, we're going to go 0.952 and then 9/8. And now we're going to look at comparing digits. When we want to look at decimals that seem like they're really close to each other, what we want to do is start at the left side of both numbers and compare the digits. And as soon as we get to ones that are different from each other, the number that's larger is the larger digit. Okay, so if we look at 1.6 and 1.4, they're both 1 point something. They both have a 1 in the first place, but the second number is a 6 compared to a 4, so 1.6 is larger than 1.4. Let's look at question B. Both are 0.5, but then the next one, the second digit is a 7 or an 8. So since 8 is larger than 7, 0.58 is larger than 0.57. And for question C, 2.95 or 2.9, when you run out of digits, you can just put a 0 at the end. So now the first two digits are the same on both of these, but then a 5 is greater than a 0, so 2.95 is the larger value.